Hi, welcome everyone. We're back. This is grade 6. This is lesson 2 in unit 7. So today we are thinking about ratios again, and we're going to be thinking about them in terms of finding a unit rate in order to calculate any amount of a ratio, which is kind of fun, and it's also a little challenging. So I have, as you can see, it's about juice. So we're on page 339 if you're following along with us in your book. I tell you what, finding plain juice that's not connected with another kind of juice, not like cherry raspberry or something like that, it's pretty tricky. So went to this grocery store this morning to find some juice. So I've got cherry juice and orange juice, and Sue and Ben are combining cherry juice and orange juice today to make their super secret punch recipe. Now, I haven't ever tried this before, so I don't know how it's going to be, but I've got some awesome testers here that are going to give us a taste test when the time is right.
Hi.
So, you just heard them talk about it. We're not quite ready for them. Well, we'll call them over when we're ready. So, here's what we're going to do. We are going to look at their 2 different recipes and see if we notice any differences. Then we're going to actually make them and taste them. All right, so here we have Sue and Ben. They're on their recipe showdown. So they both have their recipe for their world famous punch. Sue's recipe has 5 cups of cherry juice and 4 cups of orange juice. Ben's recipe has 6 cups of cherry juice and 5 cups of cherry juice. Now, what do you notice that's the same or different about the recipes? Well, hopefully you're noticing they both have cherry and orange. That's why they're having their showdown. You can't really have a showdown with, totally different things. So they have the same components. What else do you notice? Hopefully you'll also notice that they both have more cherry. Sue's has 5 compared to 4, so 5 to 4, cherry juice to orange juice. Ben's has 6 to 5. We've got to figure out which one, first of all, tastes better, because that's the ultimate end of drinking juice anyway. And we also need to figure out which one has more cherry juice, a deeper cherry flavor, and which one has a stronger orange flavor. So let's see what we can do about that. First of all, we're going to try to make these juices. Now, the thing about it is, if I use 5 cups of cherry juice and 5 cups of orange juice, if you're not familiar with measuring cups, here's a measuring cup. You can kind of see that that's the 1 cup mark. That's kind of a lot of juice. That's 1 cup. What if I filled that up 5 times? I would end up making my juice in a bowl like this, which makes sense if you're making juice for a whole bunch of people, if you're making punch, maybe you're having a party. But to just taste it, I don't really want that much juice, because what if I don't like it? Then I've kind of wasted all that juice. So instead of making it cups, the cool thing about ratios is, as long as the ratio is the same, you can change the amounts. So instead of using cups, 5 cups of cherry and 5 cups of orange, instead, I'm actually going to use, I wonder if you can see this, I'm actually going to use tablespoons, because they're much, much smaller, and that way we can taste it and decide if we like it before we use up all of our supplies and make something that we don't think tastes very good. And since this is the Sue's famous punch and Ben's famous punch showdown, we got to choose the recipe that we like better. So let's start by making Sue's famous recipe. Okay, her recipe has 5 cups of cherry, 4 cups of orange. I'm going to do tablespoons, so I'm going to do 5 tablespoons of cherry, 4 tablespoons of orange. All right, you see I've got my tasting glass here. So I'm going to pour 5 tablespoons of cherry juice. There it is. Oh yeah, you can see that, I think. So I'm going to go ahead and mix that in. Then I'm going to pour 4 tablespoons of orange juice. All right. How does that look? The color is not very good. I don't know. I'm going to have to say, I'm not sure what Sue and Ben are thinking, but that color is a little off. Here comes my super taster. All right, super taster, we're ready for you. There he is. All right, he's going to taste it. Go ahead.
Pretty good.
Pretty good.
Yeah.
All right. So far that one's pretty good. Let's try the other one. All right. So before we decide on the final recipe we might want to use, we're going to try Ben's world famous recipe for cherry orange punch. His recipe, remember, has 6 cups of cherry juice and 5 cups of orange juice. Now remember, I don't want to make a giant batch before I taste it, so I'm going to use tablespoons again. 6 tablespoons of cherry and 5 tablespoons of orange. Okay, so we need 6 tablespoons of cherry. There it is. And even though this glass looks the same, this is actually a different glass. And we need 5 tablespoons of orange. Oops, I'm showing you the teaspoons. There we go, 5 tablespoons of orange. All right. Well, I'll tell you what, the color is about the same. So let's see what it tastes like. Let's bring out our tasters. Okay, tasters, we're ready for you. All right, there he is. All right, he's stirring it up. Let's see what we got. What's the good word?
Good.
Do you think better or worse or hard to tell?
Hard to tell.
Hard to tell. Okay, grab that other one. So he says just tasting the 2 side by side, it's a little hard to tell.
This one tastes like it has more orange, and that one tastes like it has more cherry, actually.
Interesting. Okay, let's see how the ratios go for that. Okay, so it was a little hard to tell. Now, just by tasting, sometimes that might be the perfect way to tell, but if the recipes are fairly similar, like these two, but we want to know actually which one really has a bigger ratio of cherry or a bigger ratio of orange, there's a mathematical way we can do that too. So the way that our book wants us to learn right now is to find the unit rate. And if you think way back to Unit 1, you remember we talked about rates and unit rates. Unit means 1. And so it's compared to 1. So we want to get either the cherry or the orange down to 1 so that we can pair something else per 1 something. So our book says, let's try Sue's first. Instead of using 4 cups of orange, let's use 1 cup of orange. So we put 1 down. Now we need to say, okay, but how are we going to get from a recipe that uses 4 cups, how are we going to get that down to 1 cup? Well, the answer is we're going to divide. Instead of having this whole recipe, we're going to divide our recipe in 4. So to get from here to here, we divided by 4. Now remember, just like fractions, if you mess around with the top part of a fraction, you've got to mess around with the bottom part. Here, if you're going to change one side, if you're going to multiply it or divide it on one side, you've got to use the same part of the ratio, the same line, the same row, and do the same thing on the other side. So 4 divided by 4 is 1. 5 divided by 4. Now, you might say, okay, well, I don't know what 5 divided by 4 is. As a matter of fact, I think I need to write that out and work on it. You might say, okay, I've got 5 divided by 4. I don't know what that is. So I know that I can put the 5 under the dividing bar and the 4 as the divisor. The 5 is the dividend. 4 is the divisor. 5 divided by 4. I know how to solve that. You may also remember that the fraction bar is a dividing bar. We don't always think about it that way, but that's what it means. So if you're doing 5 divided by 4, you could write it as 5 divided by 4. Now, you could either that was hard for me to say, you could either leave this as 5/4, a fraction greater than 1, an improper fraction, or you could change it into a regular mixed number. So you could say, I know that there's 4/4 in there, that's 1 whole, and then there's 1 more fourth. So either one of these, 5/4 or 1 1/4, if you want to change it into a mixed number, those are all 5 divided by 4. You don't even need to do this. You can just set it up as a fraction. Something divided by something, you can use that fraction bar. So that's what our book does. Our book is showing us that we don't have to do that as a division problem even. We can just say we know 5 divided by 4 is 5/4 or 1 1/4. So now we have this as a unit fraction. There are 1 1/4 cups of cherry juice per cup of orange juice. See how we use that word per again? Per means, remember, but there's always an invisible 1. Per 1 something. So 5/4 cup of cherry juice, or 1 1/4 cup of cherry juice per cup of orange juice. What if we did that same thing now with Ben's recipe? Ben's recipe has 5 cups of cherry juice, but we still want to take it to 1. We still only want 1 cup, so we can talk about the unit rate. How did we get from 5 to 1? Well, remember the choices are multiply or divide, and we're going to divide. We want to divide by 5. So instead of having a recipe with 5 cups, we want the recipe to have 1 cup. If we do it over here, what do we have to do? I hope you said we got to do it on this side. 6 divided by 5. Again, the choices for 6 divided by 5 are 6. We could divide it by 5. We could write it like that. 6 divided by 5. We can write it like that. 6 divided by 5. We can write it as a fraction. So let's do that. Let's write 6/5. We also know that equals 1 1/5. So this one over here, I'm going to just write it in another line. 1 1/4 to 1. And this is 1 1/5 to 1. Now we can start seeing the relationship between these two. Which one is more? 1 1/4 or 1 1/5? 1 1/4 is a little more, isn't it? Because we're dividing it into 4 sections, and we have one of them. 1/5, we need to divide something into 5 sections. The sections are a little bit tinier, and we still only have 1. So this one has a little more cherry juice compared to the orange juice. This one has a little bit less cherry juice compared to the orange juice. So for this recipe, the unit rate for Sue's famous punch is 5/4 cups, or 1 1/4 cups, per 1 cup of orange. So 5/4 to 1. 5/4 cups of cherry per 1 cup of orange. The unit rate for Ben's is 6/5 cup of cherry, or 1 1/5 cup of cherry, per cup of orange. So 6/5 per 1 cup of orange. I hope that makes sense. It's a unit rate because it's comparing it to 1. But the next part of it says, what if instead of changing the orange to 1 cup, what if we wanted to tell how much was in the cherry? If we changed the cherry to 1 cup, then what would the ratio be? The ratio stays the same It's just how we talk about it that is different. The unit rate sounds and looks different, but the ratio is still the same. Just like the ratio of 5 cups to 4 cups was the same as I used when I used my tablespoons. It was still 5 to 4. That's still the same ratio if we cut the cherry juice now down to 1 cup and then see how much orange we should use. And if we cut the cherry juice of Ben's down to 1 cup and see how much orange we use. All right, let's take a look what that would look like. So for Sue's famous punch, if she didn't want to use all 5 cups, maybe she was kind of tweaking her recipe just like we did. She doesn't want to use up all of her supplies just trying something new. So she says, well, I'm going to cut it down to 1. I only want 1 cup of cherry juice. How did she get from 5 to 1? She divided by 5. 5 divided by 5 is 1. So there it goes. That's dividing by 5. Now, if we do it on one side, we have to do it on the other side. So now we got to do 4 divided by 5. What is 4 divided by 5? Well, hopefully, even though I didn't rewrite it over here, hopefully you're knowing, oh wait, 4 divided by 5. I don't have to write that longhand. I don't have to write it with the division bar. I can write 4 divided by 5, 4/5. So if Sue uses 1 cup of cherry juice, she has to use 4/5 of a cup of orange juice. What about Ben? If Ben decides instead of 6 cups he wants to use 1, how does he get from 6 to 1? He's got to cut his recipe in 6. 6 divided by 6 equals 1. If we do that on one side, we have to do it to the other one. 5 divided by 6. How are we going to write 5 divided by 6? I hope you know we're going to write it as 5/6. So each of their recipes, now we have 1 cup of cherry juice. So Sue's recipe has 4/5 of a cup of orange juice per cup of cherry. Remember when we say per, it means per 1. So 4/5 of a cup of cherry per 1 cup of cherry. 4/5 a cup of orange juice per 1 cup of cherry. Ben's, we have 5/6 of a cup of orange per cup of cherry, per 1 cup of cherry. So those are the unit rates. Going the other way, the unit rates, if we're talking about the cherry, is the 1 unit. Okay, now we have 2 more things to do with our information. One of the things is we want to graph it because they really want us to be able to see and understand how graphing the information from a ratio table can help us to kind of more deeply understand what's going on in the ratios. The second thing what we want to do is say, okay, but what if we didn't want to just make a smaller amount? What if we didn't want to make the regular amount? And what if we didn't want to make the amount that had 1 in it? What if we wanted to, and what if we also didn't want to make just multiples of that amount? For instance, we could do 5 to 4. We could double that batch to be 10 and 8. We could triple that batch to be 15 and 12. That would be easy. But what if we said, you know what, we've got a little bit left, let's just make the rest of it. What if we said, I want to make a recipe that uses 3 cups of orange? You might say, okay, but how do I get from 4 cups to 3 cups? And then what would the corresponding number for cherry be? Well, once you found the unit rate, you can multiply about anything because it's easy to go from 1 to 3. How did we get from 1 to 3? From 1 to 3, we multiplied it times 3. If we go from 1 to 3 and multiply it times 3, we're going to do the same thing over here. We're going to multiply it times 3. See how that works? Then you have 15/4 which you can then convert. How many groups of whole groups, 4/4 is a whole group, how many whole groups can I take out? You can take out 3, and you have 3/4 left. So the nice thing about finding the unit rate is once you find the unit rate and you take something to 1, you can choose any number at all because anything times 1 is itself. Makes it really easy. So let's fill in a few more examples and then let's graph it. Even though our book isn't asking us to, let's practice graphing. So you can do just what I did on a separate piece of paper. Just draw a big graph. It doesn't have to be perfect. Mine's certainly not going to be perfect, but let's graph it and see what happens. Okay, so I went ahead and filled in a few extra numbers, and I want you to see how I did that, and you can do it too, and they don't have to be the same numbers as I did. But first of all, I said, well, here's a single batch, 5/4. What if I made a double batch? What would that be? A double batch means you use the same ingredients, but you put them in twice as much. So if you've ever made a batch of cookies and then thought, oh man, I should have made more. These cookies disappeared so fast. I should have made a double batch. Means you just put in twice the amount of ingredients to get twice the size of whatever it is you're making. So twice the number of cookies. So if Sue is using 5/4 cherry to orange juice and she needs a double batch, means she doubles the cherry to 10, she doubles the orange to 8. So I wanted to give each Sue a double batch, and I wanted to give Ben a double batch. So he had 6/5. So if he doubled it, it would be 12/10. So I wanted to give them both a double batch. Then I also wanted to give them a matching batch. So this was 12. He has one where he needs 12 cups of cherry. I wanted to give Sue one where she needed 12. But 5 times something is 12. There's not a whole number, and it might be hard to figure that out. So instead of trying to say, how do we get from 5 to 12, that's where we use the unit rate. We go up to the 1. How do we get from 1 to 12? That's pretty easy. We just multiply it by 12. So if we start here and multiply this times 12 over here, then we're going to use the same one that goes along in the same row, 1 cup of cherry to 4/5 cup of orange. We're going to multiply 4/5 times 12. 4/5 times 12 is 48/5, which is 9 3/5. So I wanted to do that same thing over here. If we had 10 cups of cherry, I wanted to have for Ben's recipe. He also has a recipe with 10 cups of cherry. So how do I get from 6 to 10? It's hard to multiply or divide. We probably don't know what the answer is out of our head. But I know how to get from 1 to 10 really easily. So the book calls this going through the unit rate or using the unit rate to find any other ratio. So we're going to start with the 1. 1 times 10 is 10. That's an easy one. We use the same row, 1 cup of cherry to 5/6 cup of orange. We times that. We do 10 groups of that. 5/6. 10 groups of 5/6 is 50/6, which is 8 2/6. Now, some of those are going to be a little tricky to graph because they're parts, but do your best. We're going to try to graph those on here. Now, I've put the cherry as the x-axis going side to side. I put the orange as the y-axis. So go ahead and plot your points. Pause the video, plot your points. I'm going to do the same thing, and then we'll come back. Okay, so we're back, and I've graphed mine. I hope you have graphed yours as well. Now, I want you to notice that I added a couple more things onto the bottom. I added what we were doing from lesson 1 to try to connect what we did yesterday or in lesson 1 to what we're doing today. Remember, they told us one way to be able to compare ratios really well is to just take the products of one of the parts of the ratio, take those two factors and make a product, and then do it to the same side. So I started with this. I did 4 times 5 because the orange was 4 and 5, and so I put that as one of the sides of the ratio. 4 times 5 is 20, so I gave them each 20 cups of orange. Then, to get from 4 to 20, I multiplied by 5. So in order to get the cherry, I had to multiply by 5. So I have 25 to 20. Over on Ben's side, to get from 5 to 20, I had to multiply by 4. So I had to do the cherry by 4. 6 times 4 is 24. Then I did it back the other way. I said, what if we want the cherry to be the same? The cherry is 5 and 6. The product of 5 and 6 is 30. So what if we made both recipes had 30 cups of cherry juice? Now that's a lot. They'd have to be making it for a party. So what if they both had 30? When I change both of those to 30, 5 times 6 is 30. So 4 cups of orange times 6 is 24 in Sue's recipe. When I changed 6 cups of 30 to 30 of cherry in Ben's recipe, 6 times 5 is 30. So I had to multiply the orange by 5. 5 times 5 is 25. So I added some bigger numbers so that our graph would get a little bigger and be a little easier to see. Now, I hope you're noticing the same similarities of what we saw yesterday. When we make the graph and we make that diagonal line, cherry is on the bottom, on the x-axis, orange is up on the y-axis. When I make that black line in between, just over one, up one, over one, up one, over one, up one, so it goes exactly through the center, you'll notice that all of this side I colored red for the cherry, all of that I colored orange. Well, just by seeing where these two lines fall, you can see, even if you didn't know these numbers, you can see that they both have more cherry because they're on the cherry side of the half. If they were up on the orange, that would mean they had more orange in them. The ratio was orangier, more orange than cherry. Both of them have more cherry than orange. Now, it's also easy for us to see when we have a visual like this, it's easy for us to see which one is orangier. They both have more cherry, but comparatively, which one is orangier? Ben's line is the green, Sue's line is the blue. You can see that Ben's line is a little bit closer to the halfway mark. It's a little bit closer to crossing into the orange. That means his is a little orangier, even though it still has more cherry. It's on the cherry side, but it's orangier than Sue's. Sue's is further down into the cherry, so hers has a bigger cherry flavor comparative to the orange flavor. We can also see that by looking. Look how close the recipes are. When they both take 30 cups of cherry juice, Sue's has 1 less cup of orange juice. That's how close they are. They're very, very close recipes, aren't they? In fact, when we tasted them, it was hard for us to tell. Now, I hope, just like you hear me say all the time, I hope you're trying these things at home. Don't just watch me play with math or my family. Use it. And if you don't have cherry juice and orange juice, no big deal. Let me give you some ideas. So what about this? For people who are my age, maybe your parents' age, or even maybe your grandparents' age, this is like a blast from the past. We used to drink Kool-Aid when we were kids. So when I was at the grocery store, I found a packet of Kool-Aid, packet of orange and packet of cherry. Well, here you go. Try them out. Make up 2 things of juice, and then use a measuring cup so you can write down your data and see which one you like best. See which recipe you like best, and it might not be Ben's or Sue's. So it might be something totally different. Or maybe you decide, wow, orange and cherry, I don't know who thought that was a good combination. That is not tasty. Maybe you want to try something else. Here's one of my personal favorites. Grape and lemonade. I don't know if you think it sounds good. When I was a kid, there was a Kool-Aid flavor called Purple Saurus Rex. And it was grape and lemonade put together. Wait till you taste it. It's really outstanding. Now, I don't know what the best combination is, but hopefully in one of these future videos, we'll get to try it and figure out exactly what the ratio of grape to lemonade should be. You would start with half and half and then change it. Have fun playing with math. See you next time.